Namaste dear students. Today our topic is spherical refracting surface. Actually, a surface which separates two media of different refractive indices is called as what? Refracting surface. For example, look here. This is a surface and let us say this medium is denser medium. Denser medium in the sense it can be water, it can be glass, okay, and this medium is rarer medium, and this is the principal axis, okay. See, here it is rarer medium, here it is denser medium. These two media are having different refractive indices. Let us say this is refractive index N2 and this is refractive index N1. These two media are separated by a surface, and this surface can be called as what? Refracting surface. Refracting surface. Then what is a spherical refracting surface? Okay, so spherical refracting surface is actually initially it is going to be a sphere of which a small part is taken. Okay, see here, we shall take another diagram. See, this one is denser, let us say it is N2, and this is principal axis, and it is rarer, which is having a refractive index of N1. Okay, see, initially it was a sphere like this, okay, and this was the radius, and it is the center of curvature. Center of curvature to this point, this distance we can take it as radius of curvature. Okay, so ಇದೇನು ಸ್ಪಿಯರ್ ಇದೆಯಲ್ಲ, ಈ ಸ್ಪಿಯರಿನ ಒಂದು ಸ್ಮಾಲ್ ಪಾರ್ಟ್ನ ನಾವೇನಂತ ಕರಿಬೋದು? ಸ್ಪೆರಿಕಲ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಅಂತ ಕರಿಬೋದು. ಹಾಗಾದ್ರೆ ಸ್ಪೆರಿಕಲ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸಲ್ಲಿ ಎರಡು ಟೈಪ್ ಆಫ್ ಬಂದು. ಎರಡು ಟೈಪ್ ಯಾವಪ್ಪ ಅಂತಂದರೆ, ಒಂದು ಇದು ರೇರರ್ ಮೀಡಿಯಂ ಇದೆ, ದಿಸ್ ಈಸ್ ಕಾನ್ವೆಕ್ಸ್. ಓಕೆ, ಕಾನ್ವೆಕ್ಸ್ ಟುವರ್ಡ್ಸ್ ರೇರರ್ ಮೀಡಿಯಂ ಈಸ್ ಕಾಲ್ಡ್ as what? Convex spherical refracting surface. Convex spherical refracting surface. ಇದು ನೋಡಿ ರೇರರ್ ಮೀಡಿಯಂ and it is concave towards the rarer medium, and such a spherical surface is called as what? Concave spherical refracting surface. Refracting surface. Okay, towards the rarer, concave is there. Towards rarer, concave surface. Concave surface. Here, this is rarer and this is convex shape. Convex shape towards the rarer. Convex towards rarer. So these way spherical refracting surfaces are classified in two ways: concave as well as convex spherical refracting surface. Okay, so as we know, this point is called as what? Pole. Okay, and this is center of curvature. Initially it was a sphere. Okay, of that sphere a small part is taken. Okay, and this part now it is refracting surface, spherical refracting surface. From P to C the distance is said to be R. R is radius of curvature, and this is principal axis. Okay, so while discussing about mirrors, we had considered the sign conventions. Same way here also, if the measurement, all the measurements are to be done from pole. All the measurements are done from pole. This is first sign convention. Second sign convention, if our measurement is along the direction of incident ray, then it is taken as positive. If the measurement is opposite to the direction of incident ray, then it is taken as negative. Heights or transversal heights, okay, it means the perpendicular to the principal axis, Okay, if it is above, then it is taken as positive. If it is below, then it is taken as negative. All the sign conventions which we used in while discussing about mirror, same sign conventions are being used here also. Okay, so this is convex spherical refracting surface and this is concave spherical refracting surface. Understood? So let us start with derivation, that is refraction through spherical surface. Refraction at spherical surface. Refraction at spherical surface. For your point of examination, it is very important. Sometimes it is also called as derive an expression for the relation between n, u, v, r, where r is radius of curvature, n is refractive index, and u and v are object distance as well as image distance. Okay. For that, we shall consider refracting surface, spherical refracting surface. This is principal axis. What type of spherical spherical refracting surface is this? This is convex, because this is rarer medium and this is denser medium. Convex side of this surface is towards the rarer medium, therefore this is convex refracting surface. Okay. Let us consider one point object O. O is a point object and this is the principal axis. Denser medium refractive index is N2, rarer medium refractive index is N1. And since this is the curved surface, this is going to be the center. From center, at any surface, any point on the surface is going to be perpendicular, because if this is circle, then this is center. From the center, if you draw any line, that line is going to be perpendicular to the surface. See here, this is perpendicular. Line is perpendicular. Understood? So this is going to be our normal. Normal is always perpendicular to surface. Okay. If this is O, then from O is a point object. From O, a ray incidents at this location. Let us say this is A. And this is incident ray. Now, this ray is moving from rarer medium to denser medium. It has to undergo refraction. Whenever a ray travels from rarer medium to denser medium, it bends towards the normal. When a ray travels from denser medium to rarer medium, it bends away from the normal. As you can see here, this is normal. If this is rarer medium and this is denser medium, optically rarer and denser medium. If this is incident ray, if it is traveling from rarer to denser, it will bend towards normal. This is normal. And ray will bend towards normal like this. This is actual path. From its actual path, it will deviate towards the normal when it travels from rarer to denser. When it travels from denser to rarer, like this. If this is denser and this is rarer, this is the incident ray of light. This is the actual path. The ray will bend away from normal like this. This is the refracted ray and it has bent away from the normal. This is the normal. This is what takes place when ray travels from one medium to other medium. Now this ray has to bend towards normal, therefore this is the normal and it will bend this way. And this is going to be image. Let us say this image is I. Okay. And if this is incident ray and this is normal, let us say this is A, this is normal and this is incident ray. Therefore, this angle is going to be angle of incidence. And this is normal, this is refracted ray. Therefore, this angle is going to be angle of refraction. This is refracted ray. AI is refracted ray, okay, and this one is pole, okay. So we shall write all the things. O is point object, OA is incident ray, and AI is refracted ray, and from P to C it is radius of curvature, okay, and AC is normal ray, I can say, okay. For our convenient, let us take it as alpha and this as beta. See, alpha is an angle between incident ray and principal axis. Since the object is point object and image is also point image, okay. This is beta and let us take it as gamma, okay. See, alpha, beta and gamma, all these three angles are very small angles, and these angles are between incident ray and principal axis, refracted ray and principal axis, normal and principal axis, okay. So all these three angles are connected with principal axis, okay. Next, from Snell's law, Snell's law is the ratio of sine of angle of incidence to the ratio of sine of angle of incidence to the sine of angle of refraction is equal to constant, okay. So here sine I divided by sine R can be written as N2 divided by N1. Even angle of incidence and angle of refraction also very small angles, okay. For small angles we can take N1I is equal to N2R. Sine I have considered as I, sine R I have taken only R because angles are very small, okay. As you can observe the diagram, this angle of incidence is an external angle for alpha and gamma. If we consider triangle, from triangle OAC, I can be written as, this is external angle. External angle is equal to sum of opposite angles, sum of two opposite internal angles. Therefore, it is alpha plus gamma. Similarly, if I consider the triangle OAI, from triangle OAI, I can write, not that one, sorry, this triangle ACI, from triangle ACI, this is ACI, R plus beta is equal to gamma. This gamma is an external angle for R and beta. These R and beta are internal angles. These two internal angles, sum of these two internal angles must be equal to the external angle gamma. That is what I have written. Therefore, R is equal to gamma minus beta. This way I can write R is equal to gamma minus beta. See here, N1I is there. Therefore, N1, in place of I can write alpha plus gamma is equal to N2. In place of R, I can write R gamma minus beta. N1, see, alpha, beta and gamma, these three angles are very small angles. For small angles, we can consider tan alpha, tan gamma, tan beta also. Okay, so N1 alpha plus N1 gamma is equal to N2 gamma minus N2 beta. Instead, I can write N1 tan alpha plus N1 tan gamma is equal to N2 tan gamma minus N2 tan beta. Since the angles are very small, I can consider this way also. N1, you can observe tan alpha is equal to opposite. This is opposite. Okay. Since this aperture is very small, I can consider this as a straight also. AP divided by OP. AP divided by OP or PO. Since all the distances are measured from pole, I have considered it as PO. Plus N1 tan gamma. This is gamma. Gamma is equal to opposite divided by base. Opposite is AP divided by PC equal to N2 tan gamma. This is gamma. Opposite divided by base. AP divided by PC minus N2 tan beta. Beta opposite divided by base. Opposite is AP. Base is PI. AP divided by PI. As you can observe, here AP. All the APs get cancels. Then what is remaining? N1 divided by PO plus N1 divided by PC equal to N2 divided by PC minus N2 divided by PI. Okay. Here N1 PO is equal to, see here, this is P and this is O. From P to O it is object, therefore it is object distance. Okay. And from P to I it is image, therefore I can write it as V, image distance. With the sign convention, P to O it is object distance. Since the object is moving this way, our measurement is this way, we can consider this U as negative. Therefore, it is N1 divided by minus U plus N1 divided by PC. This is P, this is C, this is R. Since all the distances are measured from pole, we are measuring this way and the direction of incident ray is also this way. PC and object distance both are, object moment, both are in same line, therefore PC is taken as R, positive, according to sign convention. N2 divided by PC is R minus N2 divided by PI. All the distances are measured from pole. This way we are measuring and incident direction is also this way. Therefore V is also positive. Therefore it is V. Okay. N2 divided by V is taken this way, this side. So it is N2 divided by V minus N1 divided by U is equal to N2 by R, N1 by R. If N1 by R goes that way, then it is going to be negative. Therefore R is taken common, or else it is also written as N2 minus N1 divided by R. This is the final expression. And please notice here, this image is real image. Real image. And real image is always inverted image. Inverted image, and it's a point image. Point image. Okay. And you can notice here, this is incident ray and this is refracted ray. Refracted ray has bent more here. Actually, this is the actual path of incident ray. Okay. The ray has bent this much. Okay. If the ray would have bent only this much, then see here, this ray is not going to meet principal axis anymore. Okay. And in that case, what we are supposed to do is, we are supposed to draw the refracted ray backward, and this ray appears to meeting at this location, and this image is going to be virtual image. With the same situation, virtual image is also possible if the ray has bent less. Understood?